In this video, I'm going to talk about what we mean by least square regression or linear regression and how we can do that with the calculator, both make the scatter plot and find the equation of the line. Okay. So what happens in real life if you collect data and you plot it, you get what's called a scatter plot, which typically is scattered and the points don't follow any nice particular function. But we still would like to try to model it with a nice function, and the simplest type of model is a straight line. So we talk about this line of best fit, or as we're going to see, it's also called the linear regression, the regression line, or the least square regression line. We have lots of different names for it. But here's a set of x and y values, just kind of an abstract example that I made up. If you plot those in the xy plane, you get what's called a scatter plot because they are typically scattered. And you see here, as I say, no line is going to fit these points, no straight line, but we want to try to come up with what's called the best fit line. And the idea is they use this thing called the least square regression. If you were to come up with a line and try to use it to predict the y values of the points by plugging in the x values, you're going to get an error if the point doesn't lie on the line. So, for instance, if we take x equal 5, here's an actual point with its y value, and up above it you have the value on the line, and the difference between those y values would be your error in your prediction. So the best fit line tries to minimize those errors basically. But if you add up all the errors, the positives and the negatives would cancel out, so it minimizes the sum of the squares of the errors. Okay? So it's pretty complicated computations in the background, but if we're going to use our calculator or software to create the line for us, I think it's good enough if we just understand the general idea that it's minimizing the errors, the sums of the squares of the errors, which is the best way mathematically to get the line as close to the points as possible to minimize your errors in your predictions. So let me back up here. Let me show you how to enter this data on the calculator, how to make the scatter plot with the calculator, and then how to find the linear regression line. So with something like this, what we have to do is enter these points into a list, which is in the statistics menu. So on a TI-83 or 84, let me clear that out. I was doing some graphs for a pre-calculus class. So start with a blank graph. But if you hit the stat button right here beside the arrows, number 1, you can go in and you can edit. Now hopefully you see L1, L2, and L3, and if you scroll over all the way through L6, we want to put our data, the easiest thing is to put it in L1 and L2. Those can get renamed, they can actually get deleted here. You shouldn't do this, but I'm going to delete it. So now I don't see an L1. Well, if that's ever the case, just hit Stat and run Setup Editor number 5. So you hit Enter to put that on the home screen, Enter again, and it says Done. And it restored everything to default. So stat, edit, I've got L1 and L2. Okay? You can delete a single entry, but the quickest way, if you do the up arrow and highlight the name of the list and hit clear and enter, it'll clear the entire list. So I'm going to start with blank lists and then just type the numbers in. So with the calculator, we've got 2, 3. I'm going to go down the x's first. I'm going to put the x's in L1, 3.5. 4, 4, 5, 7, 9. In statistics, we would call this the explanatory variable, and then the y value, the response variable. 12, 9, 8, 7, 5, 3, 1.5, or 1/2. So I have the points in there. If you hit the second button, and then y equals, you can set up a stat plot. It is a good idea to hit y equals and make sure you don't have anything else plotted, or you may have some extra things on the screen you don't want to see. But if we do second and y equals, we can hit enter to go into plot 1. We can turn it on by hitting enter on top of on, and then with the arrow buttons we can move around, and you can select different types of graphs for statistics. We want to do the regression, or the scatter plot, and then the regression, so the picture, we would pick that picture. When that's the selection that's made, it asks you for the X list and the Y list, and you can put them anywhere, but it's easiest just to always use L1 and L2, and there they are. If it didn't say L1, you can do second and 1 to get L1. They're above the numbers. You second and 1 to get L1, second 2 to get L2. Then you can pick the symbols that it plots. I usually use the little squares because they're the largest. And then a shortcut, if you hit zoom and number 9, you can hit the number 9 or scroll down. Zoom 9 is zoom stat. It will make sure that it selects a window that shows all of the points. And you get a picture very similar to what I had on the computer. Okay, so that's how to make a scatter plot. Then on the calculator, it's very easy. You hit the stat button. Once they're already entered, hit stat, go to calculate, and you can run number 4 to get the linear model, the linear regression, ax plus b. So I'm going to hit enter. Some of the older calculators, they don't give you this menu. They don't ask you where the list is. It just pops up on the home screen with linear regression. On those, if you just hit enter, it'll automatically assume you used L1 and L2. On here, it asks you that. But again, if we all use L1 and L2, then we're set. You can store the equation, but let's don't worry about that right now. Let's just hit calculate. And there you go. So my best fit line, it tells me that the formula is y equals ax plus b, and then tells me the slope and the y-intercept. So if we round it a little bit, our best fit line would be negative 1.64, however many decimal places we want to take. So negative 1.64x plus 13.37. I always like to check myself by putting that into the calculator. So I hit y equals, and we had, I gotta move the calculator around a little bit, negative 1.64x plus 13.37. And graph, and you'll see the best fit line together with the points.